For Chapter 4, Section 3, Problem number 2. The problem was given to you, say, hey, I have a rough estimation of cosine x, which is clearly it's Maclaurin series because it's centered at 0. And they want to say what exactly is the error for this type of estimation. So, well, we have some different ways to discuss. This is essentially an error discussion. So what is the round-off error? Well, we have different ways to discuss it, but let's look at the cosine function. Its summation, k goes from 0 to infinity, -1 to the k, x to the 2k, and 2k factorial. That's the Maclaurin series of the cosine function. As you can tell, because of the flipped sign or because of this, you can realize it's alternating series. So for alternating series, the arrow, right, is actually quite easy to discuss. For alternating series, the arrow is bounded by the next term. So what is the next term? This is k being 0, k being 1, k being 2. So for alternating series, the arrow is bounded by the next term. So it is n, then that must be n plus 1. So what exactly is my next term? Naively speaking, it's supposed to be, if you just think about it, it is k being 2, right? It's k being 2. It's 2 times 2 factorial, so 4 factorial. So I want to know what's the next term, which is the term that's going to be the third term. So that's about alternating series. And we did say in class it works nicely for power series as well. So you want to know what exactly is the bound of the third term. So what's my third term? Well, once you find your n, everything else is quite straightforward. So your R2 is bounded by -1 to the power of 3, and then x to the power of 2 times 3 over 2 times 3 factorial, right? That's naively speaking how it should work out. So it is 1 times x to the power of 6 divided by 6 factorial. And what's my option of x? If you go back to the problem, well, it did tell you you want to discuss this over different intervals. For example, for the case I'm looking at right now, it says, what is the error over the interval -0.4 through +0.4? So this is bounded by whatever is x is between this and that. I think it's relatively intuitive. The larger or the smaller x is, the closer you are towards the boundary, the more extreme your value would be. So it's going to be 0.4 to the power of 6 divided by 6 factorial. So you can keep as many decimal places as needed, and then you can find your calculation relatively easily. In general, for non-alternating series, there's something that's more slightly more complicated as the formulation, but this one is just going to work out very nicely because it's alternating series. Well, I do want to point out the formulation is pretty straightforward. The only tricky part is for you to realize this problem is actually what we say happened when you're trying to estimate R2. So your n is 2. I'm not telling you how many terms I'm using. I'm literally give you every single thing. You need to realize it's corresponding to n being 2. Therefore, you need to figure out the next part is I need to estimate the following term, which is n plus 1, which is 3, right? So that's why every single k that was kept afterwards was 3. So hopefully this is helpful.